Hey guys, we're talking about the CIs, confidence intervals. So as I look at the confidence intervals, last we left in class was what does it mean? And we already discussed what it means. It means that if I have many samples, that they're going to lie within a range, and that range is referred to as the interval. And when I look at it, I'm 95% confident that the true mean values are going to lie within an interval. That takes us to the idea of problem number 12 down here at the bottom. So please take a moment to read over that. So pause. So as we look at this, we have 25 SRSs as normal population. Love that when they do that. Now here, all these little lines represent a interval of within that group. So in other words, this right here, I'm going to totally mess this up, but this long line right here is one sample in which that was the mean of that sample. Here's another one in which that was the mean of the sample, and you see how I'm messing this up. There's another sample, there's the mean. There's the mean. I better answer that. Just a minute. Okay, so back to what I was saying. So all of these, this represents the first set of samples because we have a result taken from 25 SRSs. So here is the first group, here is the second group, the third group, the fourth group, dot, dot, dot. There's 25 sets, okay, that come from a normal population. Okay, you can see right here the pink is the true mean value, okay, which means that all of these samples lie, the true mean lie within each of these samples. Remember, each line represents a group of samples. Let's try to put this in context, and let's say, dealing with the candy that we've done, let's look at this as 25 bags of candy. And with the 25 bags, we have 10 pieces of candy in each bag. So here, one bag equals 10 pieces. So that means on average, right here, whatever the average is of a specific color, let's say we've talked about Reese's so often, let's look at the average being the manufacturer saying that the average is 45%. No, well, let's just keep it nice and simple. Manufacturer said it's 50%. So that means right here, this, since I have a mu, and I'm going to change this problem to go with what we have, that's now a p. So the company says that 50% of their candies are orange. And then they sample 25 bags. Well, within those 25 bags, all of them are going to have this acceptable range. Now, this doesn't mean all of them are 50%. That means perhaps this is 50%. Let's say for the sake of argument, that's 40, that's 30, that's 6, that is 7, that's 8. But all the bags, okay, all of the bags contain 50% orange in them. So when the question is asked, out of this distribution, these distributions here, 100% of the intervals contain that true mean value. And I'm going to change it just a little. Let's say that I had a sample that was just, let's use these as two samples. If this were the case, it would not be 100% any longer. If I include these two right here that I'm highlighting in the orange, that means it would be, let's say, approximately 98% that would contain it. Why? Because here with this is that we are 98% confident that the true mean value will be between these, whatever these ranges here, but these two are outside of it. And this is with the understanding that I have 100. couple more things before I move on. I need you to keep in mind the method that we use to make these confidence intervals have got to come from the population of interest. Okay. Also, margin of error covers a chance variation, okay, due to random assignment. So here, the margin of error in a confidence interval is due to chance variation, because like we said, there's no way that every time, in terms of the Reese's situation, that every bag is going to be 50% orange. Okay, next point here, as we looked at the Price is Right, the idea of a level C. We can utilize this and say that this is a 95% confidence interval. Okay, it didn't mean it was a 95% chance of him winning. Okay, so here level C is how confident you are that the true mean is contained. How confident was that guy? Well, he was amped. You got to be confident. You got to think positive. We didn't say that there was 95% chance of him winning, and that's what the probability of 95% says, or a 95% probability says. Now I want to bypass, well, go to page 4, and I want to bypass problems 14 and 18, do them in class tomorrow. And let's talk about here specifically, like a problem I just did with the proportion, okay, estimating a population proportion. There are conditions, like I always say, if conditions aren't met, there's a problem. Has to be a random sample, okay? It has to be a legitimately designed experiment. Here, the 10% rule has got to occur, so your n has got to be greater than or equal to 10 times n, okay, or 1/10 of the entire population has got to be greater than 10. Large count condition, but please notice right here, we got n times p naught, but now, why is it the sample p? Now let's think about that. It's because whenever you're looking at these conditions, you are not given anything about the population. So it's the only p that you have available. So it is going to be n times the sample proportion, n times 1 minus the sample proportion still being greater than or equal to 10. What happens if you violate it? Well, if you violate it, it's just a bunch of nothing. Okay, if you're convenience sampling or if it's a poor designed experiment, that means why did you do it in the first place? So as we look at this next point, the general formula. The general formula is what you see right here in the pink, which is also what is on your cardstock. Okay, your confidence interval. So as you pull out a Post-it note and write on the Post-it note, because remember, you cannot write on this. Okay, but the statistic, okay, plus or minus the critical value. And as I look down here, looking at the formula, as I not scroll but lift, how this in pink equates to this. Here the statistic, which is p hat, plus or minus. Okay, at some point it stopped at me and I was just getting so excited about the stats. So let me restate this. Here, p hat plus or minus z star, we'll talk about z star again, times the square root of p hat minus 1 minus p. And as I was mentioning, that if this is being redundant, meaning I don't recognize when it stopped, your p hat is occurring here. Why? You have nothing about the population. You don't have any proportions. So with that being said, okay, you don't have any proportions about the population. All you've got is the information about the sample. So if your thoughts are, I'm going to get it confused. Well, no, because you won't be given any other p's anyway, so you're fine. The z star, which is referred to as the critical value, is based on the level C. So that's one of the things we're going to be picking up on tomorrow. So as I wrap up these notes, have a good day. Go ahead and finish your homework.